Hello everyone and welcome to this XGSLab video. This time we are going to see how it is possible to handle the analysis of interference calculation. Consider we have already imported the layout model and we are going to work with a uniform soil model. Just a very quick look to the other data input, for example the frequency. The frequency is 50 Hz. The soil model, as said, is a uniform soil model, very typical 100 ohm meters. And the layout model is this one. So as you can see, we have a model that involves basically two entities, a power line and a pipeline. We can highlight these two entities in a better way by using the option color by, and for example we can color the different entities by tag. So we can see that we have in light blue the pipeline, in green the phases of the power line, and in blue the overhead earth wire. Moreover, consider that in order to have a very quick idea of the dimension of the layout, you can switch off the grid with this option and, for example, refresh the image, and you can switch on the axis, the graduation of the axis. So you can see very quickly that we have to deal with a layout that is approximately 4 kilometers by 2 kilometers. Once we have set this, we can also switch on the background, so we can also see possible background elements, and we can also zoom an area in order to see that there are the towers, and also the different spans of the power line are represented with a sag. The sag is a parameter that we can set in the span properties. We can easily enter by double-clicking one span, for example, and the catenary parameter is exactly this. Other things we can see are, for example, very evident here. For example, we had this ZT, a transverse impedance, this longitudinal impedance, and the same here. Let's say that in this case, we have that the longitudinal impedances are used to represent insulators. So it is as if the part of pipeline that is between the two longitudinal impedances is insulated from the rest. The transverse impedances that usually are used to represent, for example, earthings of pipelines or different things, in this case are used to represent the continuity to infinity of the pipeline, and you can realize this by giving them a specific value. A specific value that is the characteristic impedance of the pipeline that you can find here in the Z0. So you can find this value, and this value can be found also double-clicking here and having a look to the data in the ZT settings, both here and also here. As you can see, the longitudinal impedance is set here, and it is 100,000 ohms, so very high impedance that is an insulator. So this is all about the data input. We can now run a debug. And if the debug is successful, like in this case, and you can read it in the message window here, the icon of the calculation is enabled and can be launched. So in this case, let's say that the calculation is quite fast for two reasons. The number of elements is not so high, and most of the elements are sources elements. That is to say that they are elements with current and voltage imposed. We can have a look at this in the phases, for example. We have that the type is source, and the source data is the voltage and the current. On the other side, the victims are more heavy to be calculated, for example, the pipeline, and here there is nothing set by the user, but everything is calculated by the software. So once the calculation is finished, we can enter the results. The table GPR and earthing impedance is empty, basically because we have no injection of current, no external electromotive force imposed, and nor reference point set. You could, for example, set a reference point by, for example, setting, let's suppose, a reference point in coincidence of this longitudinal impedance. So we should go to victim, enable the reference point and set to the start. And we have a reference point. Why have I set it to the start? Because if I enlarge this view and if I show oriented elements, I see that the pipeline is oriented in this way, from left to right. So if I select this span, I see that this span starts here and ends here. Consider that the orientation of the span is quite important, especially when you deal with interferences, because the current that is induced in the pipeline has got a sign. It could be positive or negative, but obviously this positive or negative is related to the orientation of the span. Once we have added the reference point, now we find something inside this table. Anyway, in this project, the most important thing is this other table, the additional impedances. In this table, we can find all the impedances. We have both longitudinal and transversal. For each of them, we can see the coordinate of the location where they are, the value of the impedance in real and imaginary part, and the drop of voltage along them. At the same time, we can see also the current that flows inside them. So basically, let's say for a longitudinal impedance, it is very interesting to know the drop of voltage along the longitudinal impedance. And about the transverse impedance, it is very interesting to know the current that flows inside. One more detail, you can see that this column is yellow, and according to the color code of XGSLab, you can edit this column. Especially, you can put a name. So, for example, in the longitudinal impedance, here IE, that can be seen by checking show text, this option, and generating this picture. We can see that 1E is here. We can see more clearly if we make this. So 1E maybe could be named, for example, insulator, for example, left, and 4S could be insulator right. So we can save, and if we generate again these names, we have the names here. So you can also set some names, some meaningful names, in order to orientate in a better way in your project. Obviously, this is a very simple project. In case of more complex projects, it could be very useful, this. Anyway, let's go to the most interesting part of these results. We can go to distributions. In distributions, we can select the kind of distributions. So, for example, a very interesting distribution in a case like this, it is the potential. The potential along all the spans. If we view 1D of this, we can see this, and obviously we cannot understand what this means. Why this? Because we are representing the potential along all the spans, and the spans, and with the spans I mean the spans of the pipeline, the spans of the power line, and so we can hardly recognize what is happening here. But if we use all these filters, especially the tag filter, we can, for example, uncheck the select all and check only pipeline. If we look at this, we can see the potential along the pipeline. Consider, well, you can see here, for example, these discontinuities are the places where we have the insulators. At the same time, consider we can not only represent the modulus, like in this picture, but we can also represent the real value, for example, and with zoom extent y, we can extend the y-axis in order to see everything, and also the imaginary part. We could also uncheck the modulus in this case. Anyway, the modulus most of times is the most important part. Consider that you could also see these kind of distributions in 2D and in 3D, but let's say that usually it is not as effective as the 1D representation. This kind of representations are more effective in the grounding calculations, let's say. Consider also that other important distributions are, for example, the leakage currents. In this case, the current, as said, it is very important, so we can see exactly how the current flows inside the pipeline. And this is the longitudinal current, that is to say, the one that flows along the pipeline. And for example, also the covering stress voltage, it is a very interesting case in this case. One final thing I would like to make you notice about these pictures is that you can follow the results by following the values in the box that follows your mouse. And if you have a very interesting location, you can also, with a single click with the left button of your mouse, select one location that can be also labeled location, for example 1, and clicking on OK, you can fix the box with some very interesting results, so you can highlight them. So this is all about the first results. There will be a following video, another video that will show you also other post-processing procedures for this calculation. At the moment it is all. I hope everything has been interesting to you. So see you next video. Bye bye.